Okay, what we're going to do is look at a couple of extra problems here today. We're going to look at some more problems that are similar to ones we did yesterday, where we're hopefully going to be able to write a function and come up with a solution to a real-life problem. And so in this particular case, it says we have a tabletop that's rectangular. It says the length is 2 feet less than twice its width. The perimeter is 16 feet, and we want to know what are the dimensions of this tabletop. So if there is a shape to be drawn, I would draw it. That's my first step with any problem that's a real-life problem or there's some kind of shape involved. Okay. And then the information we're given, we have a relationship here between length and width. It says the length is, and remember in math, okay, the word is generally means equals. So if I write L equals, length is 2 feet less than twice its width. Okay, 2 less than is an indication of subtraction. Okay, twice, of course, is multiplication. So if we wrote it as 2w minus 2, okay, that would be true. Okay, 2 less than twice the width. Now, they also told us that the perimeter here is 16 feet. So not only do we know that there's a relationship between length and width, and we also know that the perimeter from our geometry work is 2L plus 2W in general. Okay, and we know that that's equal to 16. Now remember that the issue here is we want to find the dimensions of this tabletop given that information. Okay, and we know that if a rectangle has a length and the width, once again the perimeter is 2L's plus 2W's, length plus width plus width, the distance around the outside. And we know that equals 16. So if we just look at this sentence right here, why can we not solve it? What's the problem? It's got two variables. Okay, so if it's got two variables in it, then that's a problem. But if we can get that down to one variable, then we can solve for that one variable. And then hopefully if we know the one variable, we can find the other because we know our relationship between the two. So with that said, if I know that L equals 2W minus 2, what could I do with that 2W minus 2 in my second equation I've written? Ashley? Sure. We could do substitution. Okay. And we could plug that in and get 16 equals 2 times, instead of L, 2 minus 2W plus 2W. And that would remedy our problem because at this point we'd now have one variable. So if we simplify the left side, combine like terms. Okay. All right, so we'll distribute the 2, 4W minus 4 plus 2W, combine the W's, 6W minus 4. If we add, we're going to get 6W equals 20. And if we divide by 6, we're going to get an answer of 10/3, or 3 1/3. And keep in mind that this is the width, be 3 1/3. And if we know the width, at this point we can plug in to the one that I circled up here and find the length, because that's a direct relationship between length and width. So if I do length equals 2 times 3 1/3 minus 2, and what I would do is if I wanted to calculate that, keep in mind if it's possible, I'm always going to do this without my calculator because I want to practice and get good at doing it without it. Okay? So, and this very well could be on the non-calculator part, so that's another reason why I would practice this, because there's really no need for one here. If you change that back to 10/3, you get 20/3 by multiplying 2 times 10/3. And then I would make this into 6/3, so I have a common denominator. 2 would be the same as 6/3. And if I subtract, I get 14/3. Okay? And if I want to write that as a mixed number, for presentation's sake, 3 goes into 14 4 times. 2 left over. So it'll be 4 2/3. Alright, and that would be our length. And if I want to get my final answer at this point, I need to make sure I have what else next to those? 4 2/3 what? Yeah, got to have some kind of unit. We're dealing with feet in this case, so we'd say 4 2/3 feet, and the width would be 3 1/3 feet. Is there any way to check that?
Yeah.
I mean, ultimately, these two answers that I put have to make the perimeter sentence true, don't they? I could put those back in there and make sure that that equals 16 if I do that. Okay. I also know that this relationship has to be true too, doesn't it? We don't really want to check with this one because we use that to find the other one. So if we put it in there again, we're just going to get the same thing back unless we made a mistake and got it right the second time. But bottom line is that these two would have to make 16 in the perimeter equation, wouldn't they? So that would be the best way to check. Any questions on any part of that process? All right, let's look at the second one here. It says the XYZ company has a fixed annual overhead cost of $150,000. Each employee generates revenues of $68,000. The company pays $40,000 for each employee's salary, benefits, and associated costs. And the question is, how many employees are needed to earn a profit of $214,000? All right. There's a hint here that's been given, which is that profit equals revenue minus cost. So anytime that we're in some kind of business venture, even if it was a lemonade stand out here on Hendershot, okay, the money that we bring in when we sell the lemonade is the revenue. Okay, the cost is how much it costs us to make the lemonade, okay, and buy the ingredients, etc. If we have to pay some employee, that would be a cost also, right? But if we take how much money we brought in and how much money we spent to do this, okay, subtracting those two would give us our profit, which we could then in turn go down to the store and buy a pop, because we probably wouldn't make that much on, especially today, right? Okay. Well, with that said, if we're interested in finding out the profit in this particular case, okay, then we need to figure out what our revenue is going to be like. Now, ultimately, we have a cost here of it's a fixed cost of $150,000. Okay, so that has nothing to do with revenue. Each employee generates revenues of $68,000. Okay, so that right there is our revenue information. But is the revenue $68,000? Okay, remember, it's $68,000 for every employee. Well, how many employees do we have? Yeah, we don't know. So it's 68,000 times what? Times X. Okay, so that would be a representation of our revenue for this company. Okay. All right, and then from there, we want to know the cost. So the cost here is twofold. We are going to pay $150,000 right up front. Okay, whoops, not comma. And then we're also going to have a cost of $40,000 per employee. So that means we're going to have 40,000 X in our parentheses. And notice that I put the whole cost in parentheses because we're going to be subtracting it. If we didn't put parentheses there and we wrote minus and plus, then that would not be right. True? So make sure that whole cost, since it's being subtracted, is in parentheses, and it's a binomial in this case. All right, and ultimately we want to know what does X need to be to make a profit of $214,000, it told us. So when we distribute here and combine like terms, we're going to have 68,000, and it's minus, so minus 40,000. So if we simplify that, we get 28,000x minus 150,000. Questions so far? All right, and then from there we will add and then divide. Get the x by itself. So if I add 150,000, that's going to be 364,000 over here. 28,000x here. If I divide by 28,000, and again, we could do this by hand, but we'll go ahead and divide with the calculator. So, Salem?
What did you do in this, like, before you actually distribute?
Ultimately, when we distribute here, this is going to be negative 150,000, right?
Right.
And then minus 40,000
Okay.
x. And remember that minus 40,000 and the 68,000 can be combined to make 28,000.
Okay.
Got a positive 68,000 and a negative 40,000.
And how did you get the 214,000?
They told us that that's what the profit needs to be.
Okay.
Good questions. All right, somebody go ahead and punch that in for me. What's 364,000 divided by 28,000? 13. So ultimately it'd be 13 fish. 13 what? You know, we're looking for a number of employees. So 13 employees. Okay, and that would do it. Questions on that one? Okay, the last one on this page I want to look at is a chemistry example. And there was one like this on our homework today, so after I do this one with you, I'm going to have you, part of your work today is going to be to go back and try that one again based on what I'm going to do here with you. Okay. The information I have is we got a beaker that contains 400 milliliters of 15% benzene, and we want to know how much 40% benzene must be added to produce a 35% benzene solution. Right. So ultimately, in chemistry, if we combine solutions with different percentages of whatever it is, whether it's benzene or some other whatever stuff it is, okay, what we want to write here is two equations in this case. Okay, we're going to write a quantity equation. So let's start with that. Okay. So ultimately, we have currently 400 milliliters of this stuff, okay, and we want to know how much of this 40% should we add to make a 35%, okay, and we're going to also make a concentration equation. Okay. All right. So we're going to start with our quantity equation. We have 400 milliliters, we know, okay, and we're going to, it says again, how much do we need to add? So we don't know how much, so we're going to write 400 plus x. So we're starting out with 400 plus x, okay, and that's going to give us some other amount at that point. So those are going to be our two variables in the quantity equation. Okay. It could be that we don't know how much of either and we know our final amount that we need. That's a possibility too. Okay, but ultimately it's still just a relationship between quantities. Okay, in other words, how much of the stuff do we need altogether? So we have 400, we're going to add a certain amount to that, and then we're going to have a final amount. Okay, we obviously don't know this because we don't know x. Okay. Now the concentration here that we have is this. Okay, we need to talk about the 15% solution, and we have 400 milliliters of the 15% solution. So if we do 400 times 0.15, that's going to give us the concentration from that particular solution. Okay. And then what we're going to do is we're going to add the concentration from the other solution. And the other solution is a 40%er that we're adding, so it's going to be x times 40%. Okay. Because again, we don't know how much of this stuff we need to add. Fair enough? And then finally, we want to create a 35%er. But how much of that 35% are we going to have? That's y, so it's going to be y times 35%. And so that right there would be our concentration equation. So in this chemistry problem, we're always going to write those two equations. We're going to write one that's about how many milliliters altogether, or how many liters, or whatever the units are for the volume. Okay? And then also we're going to write an equation that is about the concentration. And the concentration is always how much we have times its concentration, how much we have times its concentration, etc. Now, in both of these equations, they're both equations that we cannot currently solve because they have what? We have two variables. So just like we did in that first problem, can't we take this right here and plug it in for y? So let's do that. So I need, what's 4? This would not be on the non-calculator part because it would take too long to do all this. But I do 400 times 0.15, that'd be what? 60. So we got 60 here plus 0.40x. And then over on the right side, we'd have 0.35 times 400 plus x. Okay. So once again, I would distribute on the right side. I need 0.35 times 400.
140.
So 140 plus 0.35x. And then I would get the x's together by subtracting 0.35x. And I would also subtract 60 at the same time. I'd get 0.05x over on the left. And I would get 80 on the right. So again, just solving that equation. And if I divide by 0.05, how much of the x do I need? 80 divided by 0.05.
6,600.
6,600. 1,600. 80 divided by 0.05 should be 1,600. All right. And how about the units on this? X, remember, is the amount of the 40% solution we need to pour into this thing. So it would be, we need to pour in 1,600 milliliters to get that done. Okay. All right. And ultimately, with that, we knew x, if we needed to find y, we don't need to find y in this problem because it just said how much of the 40% do we need to add. So we're done at this point. If we needed to find y, of course, though, there's a relationship between x and y right here. True? Okay, we could figure out the total amount we'd have at the end if we did that. Okay, think about, does that make common sense? That much of it? Okay, if we have 400 of 15%, we need to bump it all the way up to 35%. Okay, and we're only using 40% solution. Would it make sense that it's quite a bit?
Yeah.
Okay. Now, if we got something like less than 400, would that make common sense? No. Okay, so again, think about your answer here and make sure when you get done that it makes common sense. If it doesn't, then maybe a mistake was made somewhere in your algebra. Okay. All right. Questions on that one? So again, key issue is the two equations. One's going to be about the quantities. One's going to be about the concentration.